Right, I'd like to now call on Team 3, which is Team on the Rocks. In the apprentice category, Ben Kay will be presenting, and it's on innovations in 3D projections and presentation of geoscientific data.
G'day, my name's Ben, and I'm talking on behalf of the team on the Rocks. So we're from the University of Adelaide, and we entered into the apprentice category. So who we are, we're a team of undergraduates ranging from first year to fourth year. Some of us are just about to complete our undergraduate in the next week. And like I said, we're all from the University of Adelaide, and our submission was done as a 6-week summer research scholarship, which was supported by the University of Adelaide. So just a quick overview of the submission. So just go through the dynamics of the team and what data sets we chose, why we chose them, and data integration, where we pretty much looked at wavelet transforms and the fractal dimensions of some geophysical and topographic data, and then go on to the data visualization, where we use pretty much 3D projections, and lastly on the impact on the exploration community that it might have. So just a quick overview. Main one here I want to put out is Asana. We used it's an app, a product management app. It's pretty much tracking your workflow, and it keeps up with your goals, and it's either on the desktop or on the mobile. And this is probably our main method of actual communication. So there's a lot of these workflow apps coming through, product management apps, and so our main data sets chosen, it's pretty much the backyard for us. So it's the Gawler Craton and Broken Hill. So Australia is an old continent, and much of the remaining mineral wealth, it's all under post-mineralisation cover. So it's this trying to see underneath the actual cover. In Australia, it's getting harder and harder. Australia's pretty much 80% is all undercover, and most of the minerals that have been found, the deposits, it's all been outcrop scale or very near surface. So there is quite a few initiatives. Probably the main one is the actual uncover one. So the latest report came up about 2 months ago, and this is just a collaborative effort between the government, geological surveys, industry, and academics to address this issue of seeing undercover. So for data integration, we're just trying to look at new ways of presenting data in a 3D sense. To do this, we use the continuous wavelet transformation and derive the fractal dimension. This is just trying to get more out of existing data sets. So the wavelet transforms. There's one of the advantages of the actual using a wavelet. You're analyzing a function. It's localized in time and space. So it lets you study features locally, and the detail is going to be matched to the actual scale of that wavelet. So there are lots of wavelets. Then one we ended up choosing was the Poisson wavelet. So it's really good for potential data, and it's really good at showing the boundaries between features. So this image on the left side is just showing depth slices at different intervals from the wavelet transformation of the TMI data, while the right side is just a stacked image of depth slices. So the wavelet, it's pretty much acting like a bandpass filter. So it's at the high scales, you're going to have high frequencies, you're going to be near surface. And we're pretty much generating a 3D volume from a 2D data set. And I guess you'd almost say it's a scaleogram. So it's another way of actually saying what the wavelet transformation for the 3D part of it is. This code was supplied by John Kirby from Curtin University. It's all open source, it's all freeware. So this is just run through MATLAB. To try and keep the costs down, we wanted to be able to run it on simple laptop i5, about 5 minutes processing for this data. So just one of the features around here. So in the center part around this one here, they got the Mount Wood domain. So when it's when it comes up with a near surface, This is where you got the carpinteria, you got and so it's around this way here. So you're sort of seeing those features at the near surface as it's going through. You got OD down in the bottom corner on the right-hand side of this image, down here, and Challenger mine just down the bottom as well. So again, this is just the wavelet transformation of the gravity data, just showing the depth slices. The image on the left side is just showing the actual original gravity. Again, as you can see, it's sort of acting like a bandpass filter. And when you got those, the higher frequencies showing the shallower depth, you do have, shows the features pretty well up there in the center. So just around this part here, so you got the carapatina and so on. So fractal dimensions. So it's a hard topic. I don't fully understand the maths myself, and I'm studying geophysics. So, but all I would say is that many physical and geophysical phenomena are fractal in nature, topography, gravity fields. So the essence is just by looking at the slope from that wavelet transform, it gives us a good approximation of the actual fractal dimension. So with the image on the side here, so it's showing the topography. So it's almost the paleodrainage channels that's showing up really nice on this. Would we have seen this normally? Not necessarily, you could have. So the high pass filtering could have worked. So for the data integration side, we've pretty much overall been able to produce a 3D volume from a 2D image that can show depth slices at certain intervals. It's enabled us to review certain aspects or different aspects of the data and be able to highlight some features. Just one point on this, the actual data we've been using, so it's the issue of scale and it's also the computational power. So each of our data points here for the TMI or the grav, it was all sampled at 1 kilometre. So if you try and sample that closer, smaller scale, probably be able to reveal a few more extra features as well. So for visualization, there's a lot of exciting new stuff that's happening. You just have to go inside the actual trade display and look at the Kigon booth. They got the VR headset there. So many of these are interactive. They're allowed to use it to navigate, filter information, a mouse, finger point, or even just a hand gesture as well. But overall, it's VR, AR, they're going to be successful, but the problem is there's a bit of a disadvantage when it comes to that. It's unsocial. Once you put the head face on, you're limiting yourself. So unless you can actually connect it with other headsets. So we trying to go along some way like that. So our design was to try and increase the actual social interaction through the engagement of 3D visualized data. So the basic idea was to involve the projection of data onto a 3D surface. This is done by the data being projected onto the actual, so you'd see just down here, so projecting here onto the mirror onto a 3D model type thing. So these images all designed in freeware, so that's SketchUp using to design these mock-ups here. It's lucky that one of our people in our group was an ex-architect student as well, so it made it really good. So these are just the 3D models of the DEM data. So this is all done in Blender. It's an animation freeware app. It's all open source. And it surprisingly doesn't actually take that long to learn these new software programs. So, and to run it, simple i5 laptop will be able to do it pretty easily. So it's because we're actually projecting the data onto the model. So we had to look at what type of actual plastic to use for the 3D printing. So in the end, we went with the semi-transparent plastic. You see on the image here, so this side on the left here, that was actually with it's a clear plastic that was used, and against this one here, which was semi-transparent. So it just enabled pretty much, it shows a bit more complete image. And just the image on the right side, that's the full model of the Broken Hill data set. So we did have a bit of constraints on the 3D printing. So the 3D printer sizes, dimensions, to actually use a large 3D printer, it's expensive, so we had to stick it with cheap ones to keep the budget down. So these images here just show the actual projection of the data onto the 3D printed models. So it sort of relates the wavelet transform data to the actual digital elevation model. So the DEM, which we actually use, it's one type of surface. You print whatever type of data you need, and you can project the data onto that. It gives you sort of a physical platform for the visualization of data on a 3D surface. It adds that social interaction between the user, the data, and other people. So you can still other developments that you can actually add to this. So there's these little leap motion units, just plug and play USB, and it's pretty much, it gives you an extra element where you can actually interact with the display as well. So you just use your hand gestures, so you just swipe across and you can change the image that's actually displayed on there. So, and to try and make this a bit more portable, instead of doing how we had the actual projecting of the data on the mirror, 45-degree angle, you can project it underneath to make it a lot more portable as well, to decrease the footprint. So potential impact, there's more to mineral exploration than just finding rocks and the next deposit. It's about that further engagement, meaningful engagement with the wider community, stakeholders, have that social license to operate pretty much. So we think this could have a potential to engage the wider community. So it's intuitive, it's easy to use, portable, so easy to set up, easy to move, affordable, it was cheap. So talking about 200 less. So it's accessible, everything we used was open source, so freeware, stuff like that. So it's engaging, it's got that interactive element to it. So usable, different platforms, iOS, it can work on all that stuff as well. So it's sort of what we've been done. It's been about changing the way you look and interact with data by integrating data with that social engagement as well. Thank you, and just like to thank my mentor for this, Graham Heisen, and again, Friends of Frank from organising as well and hosting us. Thank you.
Any questions for Ben? So you didn't put that last slide in just for Donna, right? Social engagement. Right? Dorothy Dix, right?
That was our first team meeting.
I love it. Okay. Thank you and your team.
Thank you.